Hi everyone. In this video, I wanted to talk about a few strategies for graphing lines. All right, so let's start by doing a couple of basics here. First, let's take a look at the graph here on the right. Okay, so the graph is made up of really you can think of it as two parts. Here you have the x-axis, and then you also have the y-axis. Okay, so this is if you're going to graph a line and you're going to find points for that line, they're going to be of the form x, y. Okay, so your x value is how far along left or right you're going to go on the x-axis, and your y value is how far up or down you're going to go along the y-axis. Okay, so if x is positive, you're going to go to the right. Your x value. So if x equals 2, you'd go to the right 2 on the x-axis. And if your y is positive, you're going to go up. If it's negative, you're going to go down. So if y was 2, you'd go up 2. And so you'd have the point 2, 2, and that would be right about here. You go to the right 2, and then you'd go up 2. Okay? So that's basically how the graph works. All right, so now let's take a look at some examples here. One option you always have available to you when graphing lines is you can plot points. And this is actually a really good strategy. This is especially a really good strategy for all sorts of functions when you don't necessarily know what the shape is going to be or what it's going to look like. It's pretty hard to go wrong here. The one huge downside to it is that it's very time consuming. So we'll see some more efficient ways to graph lines here in a few minutes. But to start with, let's start by doing a table and plotting some individual points. Okay, so we start by making a table with x and y values. And we're only going to need 2 or 3 of them because we know up front this is going to be a straight line. Okay, we're told this is a straight line, so you only need to connect 2 or 3 points to get a pretty good idea of what it's going to look like. So what we do is we start by plugging in x values and seeing what the y values are given our equation. So for this one, we have y equals 2x. So let's start with x equals 0. If we start with x equals 0, we'll get y equals 2 times 0, which is just 0. So our x value is 0, and our y value is 0. So we're going to have the point 0, 0, which is right here at the center. So let's go ahead and graph that point. And we get that because we go 0 to the right and 0 to the right or left and 0 up or down, right? So we're just going to keep that right there in the middle. Let's say we wanted to have x equals 1. Okay, if we have x equals 1, we would have y equals 2 times 1, which is 2. So our x value is 1 and our y value is 2. And that means that our point is going to be 1, 2. Okay, so what we would do is we would go to the right 1 along the x-axis, okay? And then we would go up 2 along the y-axis. So over 1, then 1, 2, and this is going to be our next point. Okay, let's try another point. Let's do the point x equals 2. So we'll have y equals 2 times 2, which is 4. So our x value is 2, our y value is 4, so we'll have the point 2, 4. So we would go to the right 2, and we would go up 4, and that would be our next point. And once we have 2 or 3 points, we can go ahead and connect the dots. And that's going to be the basic shape of our line. Okay? Let's try another one. Here we have y equals 1/3 x. Okay? So let's make our table. We have x. We have y. Let's start with 0. It's always a good place to start. So we'll have y equals 1/3 times 0, which is 0. So our x value is 0, our y value is 0, so we have the point 0, 0. And we would again fill in the center here. Okay, but we don't necessarily have to go directly in order. Sometimes you can get somewhat strategic about this. If we were to plug in the point x equals 1, which would be kind of the next, immediately obvious step, we would end up with y equals 1/3. But we notice that our graph here is given in increments of 1. And so maybe you want to choose an x value that makes more sense with that. Now, don't get me wrong. There's nothing wrong with choosing x equals 1 and then getting y equals 1/3. Then you would plot the point 1/3. That would be totally fine. There's nothing wrong with doing that, but sometimes it's easier if you choose values that make a little bit more sense with the problem, okay? So let's try maybe the point x equals 3. If we choose the point x equals 3, we would get y equals 1/3 times 3, which is 3/3, which is 1. So our x value is 3, our y value is 1, so we would have the point 3, 1. Okay, so we would go to the right 3, and we would go up 1. Okay, maybe, and we can also do negative versions of this as well. So let's try maybe -3. So we'd have y equals 1/3 times -3, which is going to give us -3/3 or -1. So we would have the point -3, -1. So here we would go to the left 3, 1, 2, 3, we go down 1. And now that we have 3 points, you can very easily see what the basic shape of our graph is going to be. Okay, so you've seen a pretty surefire way of doing this. This would work for almost anything we're going to do in this class in terms of graphing, but fortunately we have a much faster way of graphing once you learn the technique, okay? So that is when you are given a line in slope-intercept form, or if you're able to put the line in slope-intercept form. Okay, so slope-intercept form is a line of the form y equals mx plus b. And here our m value is our slope, okay? And our slope is given by rise over run. And we're going to see what that looks like here in just a minute, what that meaning is. And our b value here is something called our y-intercept. And we're going to see what that looks like here in just a minute as well. Okay? So let's start here with y equals -1/3 x plus 2. Okay, so the first thing we want to look at is our y-intercept. So this value 2 here, this is our y-intercept. So this is the point that we're going to graph along the y-axis. Okay? So the reason we call it the y-intercept is that if we set x equal to 0, so in this case, if we have y equals -1/3 times 0 plus 2, we'll get 0 plus 2, or just 2. So we would have the point 0, 2. All right, so this is the point that we're going to graph when x is equal to 0. And this also happens to always be the point where it crosses the y-axis. So we call this point the y-intercept. So anytime you see this, if you see a line of the form y equals mx plus b, you can go ahead and plot that b point on the y-axis. And this is going to be your starting point for plotting a graph of a line. The next thing that you're going to do is you're going to look at the slope. In this case, that is -1/3. Okay? So our slope here is given by rise over run, and what that's really saying is it's telling you how steep your line is. Okay? So, and also it's telling you how steep it is, and it's telling you whether or not the line is going up or whether it's going down as x gets larger, okay? If you have a negative number, the line is going to be going down as x gets larger, and if you have a positive number, the line is going to be going up as x gets larger, okay? So, let's go ahead and see if we can plot some points here. Okay, so, this rise over run is going to tell us how to get to our next point. So we can think of this -1 here as our rise. So our rise here is going to be -1, and our run is going to be 3. Okay, so this is our rise, this is our run. Okay? Rise means how far along the y-axis you're going to go and in which direction. So in this case, we have our rise is -1. So that means we're going to go down 1 along the y-axis. And we have a run of 3. So that means we're going to go to the right 3. So we're starting at this point here. And we're going to go down 1. And we're going to go to the right 3. So our next point will be here. Okay, and we can do it again. We can go down 1 to the right 3. And this is basically what our graph is going to look like. We can connect these dots, and we have a pretty good idea of what that line's going to look like. Okay, and these little arrows at the end here imply that this line goes on forever in either direction. All right, let's look at this next one. Here we have y equals 1/2 x minus 2. So the first thing we notice is our y-intercept. We use green here. Okay, so our y-intercept is -2. So we're going to go ahead and go down 2 on the y-axis. And our slope is 1/2. So our rise is 1, and our run is 2. So what we're going to do is we're just going to start from this point. We're going to go up 1, and we're going to go to the right 2. We can do it again. We can go up 1 to the right 2. Do it again, up 1 to the right 2, and again, and again. Okay, but it's also probably important to note that our slope here is 1/2. This is also the same thing as -1 over -2. Okay, hopefully we can see that. And the reason for that is that these negative signs would cancel. So if we get -1 over -2, this is the same thing as +1 over +2. So we can also treat this as going down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. And you can get as many points as you want this way along the graph. Okay? So you can really go in either direction if you know how to rewrite your slope. Okay, let's take a look at this one. Here we have y plus x is equal to 3. All right, so y plus x is equal to 3. This is not quite in slope-intercept form. Remember, our slope-intercept form is given by y equals mx plus b. So we need y isolated by itself on one side of the equal sign. So to do that, we're going to take x away from both sides. This will cancel, and we're left with y is equal to -x plus 3. Okay, so here, our slope is actually going to be -1, because we can kind of think of this as -1 times x plus 3. Okay, but -1 is also equal to -1 over 1 x plus 3. So in this case, our rise is going to be -1, and our run is going to be +1. Okay, so our y-intercept here is also going to be 3. So let's go ahead and graph that. So we go up 3. And then we have a rise of -1. And then we go a run of 1. Okay, down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. And you can continue that as long as you want. And so this is going to be the basic shape of this graph. But what about the circumstance where you're given something like y equals 2 or x equals 4 in these two cases? Well, in these cases, these are going to be horizontal and vertical lines, respectively. So if you see like this one here we have y equals 2. How you can think of this is you can think of this as all points on this graph that are given by x2. So you're fixing the y value here at 2. So x is allowed to vary freely. And so what are all of the points on the graph such that the y value is 2? Well, that's just simply a horizontal line at y equals 2. Okay, so this is all of the points on the graph such that the y value is 2. So anytime you see y equals something, you're just going to count that distance on the y-axis, and then you're going to draw a horizontal line there. Okay, well, here we have x equals 4. Very similar to the last one. This is all of the points on the graph that are given by 4y. So we're fixing x at 4, and we're allowing y to vary freely. Okay, so we would, on this one, it's the exact same idea, except now we're going to count over 4, on the x-axis. And now we're going to have a vertical line. So now our y value, the y-axis is allowed to vary freely, but we're fixing the x-axis, we're fixing the x value at 4. Okay, so anytime you see x equals some number, you're just going to count along the x-axis in whatever direction you need to that value, and you're going to draw a vertical line there.